Hello and welcome back to the course on machine learning. And in this section, we're kicking off the tutorials for hierarchical clustering. All right, so another very interesting topic ahead of us. And as always, let's make the complex simple and demystify what it's all about. All right, so what is hierarchical clustering? Well, believe it or not, but if you have points on your scatter plot or data points like we looked at previously, this is a two-dimensional space. If you apply hierarchical clustering, or let's just say HC for short, what will happen is you will get clusters, again, very, very similar to k-means. In fact, sometimes often the result can be exactly the same as k-means clustering. But the whole process is a bit different. So let's talk about it in a bit more detail. So the first thing that we need to note is that there's two types of hierarchical clustering: agglomerative and divisive. So agglomerative is the bottom-up approach, and you'll see in more detail just now what that means. So we'll be starting at the very bottom and then building our way up. Divisive is the opposite, starting at the top and dividing the clusters into multiple. In this course, we'll be focusing on the agglomerative approach. The divisive, we'll mention it a bit just now when we're talking about the agglomerative, but it's basically the same thing, but the other way around. It's the reverse of the agglomerative. And if you like, you can definitely research more about the divisive approach. But for now, we're going to focus on the agglomerative one. All right, so the agglomerative hierarchical clustering. How does it work? Well, to start off, we're going to break it down into a step-by-step approach, and then we'll look at an example and manually perform the clustering. All right, so step one in HC is to make each data point a single point cluster. So that forms n clusters. So if you have n data points, your first step is to look at each one of them as an individual cluster. Then step two is to take the two closest data points and make them one cluster, so to combine them into one cluster, and that forms n-1 clusters. Then step three is to take the two closest clusters out of the ones now that you now have and make them one cluster. That forms n-2 clusters. Then step four is to repeat step three until there's only one cluster. So basically, you just keep repeating step three and combining points into bigger and bigger clusters until there's only one huge cluster left. So you just keep repeating step three, and at the end, you're done. So at the end, you'll have one huge cluster left. And how to get from one to two or three clusters, how to get the final result that you actually want, we'll talk about that in this section as well. So that's the goal, of course. But one thing that stands out here is the words closest clusters. Now, we've already talked about distances, and we mentioned Euclidean, that you can use Euclidean distances or other distances, and that's totally fine when you're working with individual points. But here we're actually going a step even further, and we're talking about not just the proximity of points, but actually proximity of clusters. And this is something worth noting. So I'd like to pause here for a bit or like kind of step to the side and talk about the closeness of clusters and how you measure distance between clusters, because that can really affect your algorithm if you're using hierarchical clustering. So let's talk about that for a few minutes. So first of all, Euclidean distance, just to get this out of the way once and for all. Euclidean distance is in a two-dimensional space. It's calculated like that. So the distance, so if you got 2 points, P1 with the coordinates x1 and y1, P2 with coordinates x2 and y2, then Euclidean distance, or the length of this line, is calculated as x2 minus x1, so that the distance between the x's squared plus the distance between the y's squared. So basically, and then you add them up and then you take the square root. So basically, it's you've got a right angle triangle over here, and you've got the catet here, and you got another one catet here. I hope I'm pronouncing this right. And then this is the hypotenuse, right? So that is how you calculate the distance between the 2 points. So it's basic geometry back from high school, and there you go. That's just how Euclidean distances are calculated, and that's what we're going to be working with. But again, there are other types of distances that you could be invoking in your algorithms, and it really depends on the scenario and what exactly how your algorithm is going to be structured. But in our examples, we're going to be working with Euclidean distances because they're the more natural type of distance. And now let's talk about the distance between two clusters. So let's say you have two clusters, the red and the blue. How do you measure the distance between them? What is the definition of the distance between two clusters? It's not as obvious as it might sound at the start, because there can be a couple options. For instance, you can option one is just take the two closest points and measure that and call that the distance between the two clusters. Option two is actually take the two furthest points and call that the distance between two clusters. That's also a valid approach. Option three, take the average. So take the average of all the distances between the different points in the cluster, so all the combinations of different points, and take the average of that distance. Option four is take the distance between the centroids. So find the centroids and find the distance between the centroids and call that the distance between the two clusters. So it's a very important part of hierarchical clustering, what you define as the distance between two clusters, because that can significantly impact the output of your algorithm. Now, we're not going to delve much deeper into this. It's just something to remember, to note, and based on your particular situation, whether it's a business problem or other type of data science problem, based on what exactly you think is the best approach, you're going to need to define that in your algorithm. So just keep that in mind, that for the hierarchical clustering algorithm, the distance between clusters is a crucial element, and you need to remember what exactly you're setting it to be, how you're defining it in your approach. All right, so we've talked about that. Now let's move back to our example. So we've already looked at the step-by-step rules, and I'm a big fan of a step-by-step approach. Now we have that step-by-step approach, and it might have seemed a bit overwhelming as always because we didn't have an example, but now we're going to have that example, and we're going to look at how to build those hierarchical clusters. So step one, make each data point a single point cluster. That forms 6 clusters. Let's have a look at that. You can see every single point is a separate cluster. Next, take the 2 closest data points and make them one cluster. We can see that these 2 points are the closest, so we're putting them together in one cluster. Now we have 5 clusters, 1, 2, 3, 4, and these 2 are one cluster. All right, step 3, take the 2 closest clusters out of the ones we had and turn them into one cluster. So out of the clusters we had, because remember each point out of these 4, so if I go back here, each point here is a separate cluster and this is a cluster. So now just measure the distances between clusters. And let's say in our example, we're going to be talking about the distance between clusters as the minimum distance. So that would be the distance between those 2 clusters. That would be the distance, that would be, and so on. So you measure all the distances between clusters and you find out that these 2 are actually the closest clusters, and you combine them into one cluster. Next, you repeat step 3. So next, out of these clusters, out of 1, 2, 3, 4 clusters, so you can see we had 5, now we have 4. Every time you're reducing the number of clusters by 1. Out of these 4 clusters, which are the closest? Well, this seems as the closest cluster, so we're going to combine that. Now, out of these 3 clusters, which are the closest? Well, it looks like these 2 are. So you're combining them. And now we've only got 2 clusters left, so the last step would be to combine them because they are by default going to be the closest. So there we go. And so that is the end of our algorithm. That's how it converges. We've gone through the process of going from all points seen as an individual cluster, so each point is an individual cluster, to now we only have one cluster that combines all of the points. And so what's the purpose of all of this? What's the purpose of this exercise? The way the hierarchical clustering algorithm works is that it maintains a memory of how we went through this process. And that memory is stored in a dendrogram. And that's exactly what we're going to talk in the next tutorial. And once we've covered the dendrograms, it will make total sense why the hierarchical clustering algorithm does what it does and how it works. So hopefully you enjoyed today's tutorial. Can't wait to see you on the next one. Until then, enjoy machine learning.